I want to take a trip back to chapter 3, the finance section. Remember we had those couple of formulas, future value and present value? They were annuities. Back then, those formulas were just something you memorized. You didn't really care where they came from, and that's fine. But here, we actually get the opportunity to see where they came from. You may be thinking to yourself, well, this adding all these geometric terms together, it's kind of like exponential, because a geometric sequence or geometric series is multiplying the next term by by the same number every time. So let's take a look at how that connects to this future value. Remember, future value's formula was this. This is the mess that you had on a formula sheet. Again, you didn't really care where it came from. No big deal. Well, the concept behind an annuity is that you were paying every month, let's say, the same amount of money. So that first month, you just had, let's say, $50. The second month, you put in a new $50, but that first $50 is earning interest. Then the third month, you have a new $50. The first $50 is now earning its second bit of interest. The second $50 is earning its first bit of interest, and this new $50 you put in isn't earning any interest at all. So what we're going to do here is write that all out. We're going to call capital R your monthly payment from the formula, and we're going to express these terms backwards. So that first amount that you put in, that first R value, that first $50 you put in, collected interest every single month except for the first one. So if it was the 30-year loan, it would be 360 minus 1 months. So n minus 1 months. It collected interest n minus 1 times. Then the next one, n minus 2 times, etc. until the third to last payment only collected interest for 2 months, the second to last payment only collected interest for a month, and that first payment, or that last payment, didn't collect any interest at all. It was just your last payment, and you had finished saving up what you wanted to save. Well, this is a geometric series, a geometric sequence being added together. It's like R is your A sub 1, and I know that was your last payment, but we'll call it A sub 1 because it didn't have a multiplier on it. Then the next one is A sub 1 times R, and then A sub 1 times R squared. And finally, that first month that you put money in was A sub 1, and that's collecting interest for n minus 1 months. So it's like our little r in a geometric series is 1 plus I. That little 1 plus I. This is the multiplier that's happening every term. So what we learned from our formulas, when we add all the terms of a geometric sequence together, that shortcut is the first term times 1 minus r to the n over 1 minus r. So over here, our future value can kind of be set up using that formula, since it's the sum of a geometric sequence. The first term in this case is going to be r, that's our a sub 1. Our little r value is 1 plus I, so you were wondering where that came from, maybe back in chapter 3, but that's where it comes from. And then now we simplify the denominator. 1 minus 1 is 0, and then and then you just have a negative I left over. Now we don't want that negative in the denominator, so I'm going to take the negative 1 that's being multiplied by I here and distribute it to the numerator, which means in the numerator 1 plus I to the n is now going to be the positive term, and the positive 1 is now going to become a negative 1, and we've got our formula. So future value is a great application of what this adding terms of a geometric sequence is doing. We're collecting different amounts of interest depending on when you put in this money.